Hello dear students, good morning to you all. I hope all are doing good. Yeah, I hope results have announced, right? So congratulations dear students. I hope you have got very good results and you are very happy with your results. Okay. Have you got the results? Did you check your marks? Good morning everyone, good morning. Yeah, I had my breakfast. I hope you had so. Good morning Avanthi. I think around 11 o'clock I guess, right? Yeah, it is good. Possible, try to attend the offline classes. Okay. So all the very best. I think results hopefully are going to release very soon. Very soon. So hopefully you will be getting very good marks. So good morning Nissi. So don't be panic if you are getting less marks, or like whether you are getting good marks or like the marks which you have not expected. No, don't worry. Okay. So hopefully you will get very good marks. In case if you are not getting the results which you are expecting, then no worries. Okay. Right. So in last class we have studied the hybridization concept. I have given a short trick method for prediction of hybridization of central atom in a given species, and we have discussed few examples of prediction of hybridization. We will be continuing with a few more examples. Okay, we will try to apply the hybridization concept for prediction of hybridization of carbon in hydrocarbons, and along with we will work a few more interesting examples. Okay, shall we start the class? So I think you are attending the online classes. So if you are going to attend the offline classes once after conducting a few classes, so you may be having like an exam. Okay, right, let's see if possible then. Okay, I'll give the formula also for prediction of hybridization. I have given a short trick method. By using this method, we don't need to substitute in a formula, no need of any simplification. You can easily predict the hybridization. The advantage of the trick which I have given, in future you will be able to know. Not only prediction of hybridization, you can even predict the shape of a given species. Okay, right. So with this we will start a few more examples, working few more examples on hybridization topic. Okay, let's start. So try to predict the hybridization of, once again before going to work on examples, let me brief out the shortcut method which I have given for prediction of hybridization. Okay, if any of you have not attended the last class, with this formula we can easily predict the hybridization of a central atom for a given species. Okay, right. I think you have got the results, right? I think around 11 o'clock I heard like results will be announced. I think already it's crossed 11 o'clock. Okay, right? Okay, good. To find the hybridization of a given species, I have given this method. Number of hybrid orbitals is equals to total number of surrounding atoms I mentioned plus total number of lone pairs. Total number of lone pairs. Okay, right? So total number of surrounding atoms is itself the total number of sigma bonds. Okay, sometimes we may not predict these sigma bonds directly. That is the reason why I have given the total number of surrounding atoms. Total number of surrounding atoms count is equals to total number of sigma bonds. As we know this point, pi bond forming orbitals are not hybridized. Therefore, we are not counting the number of pi bonds. Okay, right. Fine. So, number of surrounding atoms plus total number of lone pairs. It is in case of a neutral species. Neutral molecule. Neutral molecule means the given molecule without any charge. The species without any charge. You can consider this as a formula number 1. Number 2, you can apply it for negatively charged species, even for positively charged species also. Again the same thing, total number of sigma bonds I am writing plus total number of lone pairs plus A I am writing over here. This is for anions. For anions. Negatively charged species is called as anion. Right here, what is A here? Here A stands for, A is representing the units of negative charge. Okay, for each unit of negative charge, you need to add 1 electron. Add 1 electron for each negative charge, where A is representing number of units of negative charge. If anyone has missed the class, you can note down these points, by using which we can easily find the hybridization of a given species. It is the total number of, again, sigma bonds along with total number of lone pairs minus, here C I am writing. This is applicable for cations. Cation is positively charged species, where C represents units of positive charge. Units of positive charge. If possible, try to note down or take a screenshot of these points. Okay, here what we need to do, subtract. Here I have written the same symbol. That is the reason why I have written negative here. Subtract 1 electron for each positive charge. You don't need to do anything here. Just I have given negative sign itself. You need to take the just in place of C, just write the units of positive charge. Okay, if possible, try to take the screenshot of this, and I'll give other formula also. There is a formula to predict the hybridization. I'll give the formula also. Whichever is convenient to you, you can use it. Okay. So just quickly take the screenshot of this one. Oh, very good. Some people are sharing the marks which they have got. Good. Good to hear that you guys have got very good marks. Congratulations to you all for achieving very good marks in your 10th board examinations. Okay. And all the best for your future endeavors. Okay. Right. I hope this was finished. Now moving ahead. Now the formula I am giving here for prediction of one formula I am trying to give. Just by using this formula, we can predict the hybridization. So whichever is convenient to you, you can just use. Okay. 1 by 2 into V plus M plus A minus C. Okay. Let me write the details of these symbols, where V stands for number of valence electrons, total number of valence electrons of central atom, valence electrons of central atom. Fine. Now M stands for V, I have written. Then try to write the information about M also, where M is total number of monovalent surrounding atoms. Monovalent surrounding atoms. Surrounding atoms. Okay. It means we are including only the monovalent atoms. Okay. Here I am writing a point. No need of including. No need of including the total number of divalent or trivalent atoms. You must include only total number of monovalent surrounding atoms. Then no need of including divalent surrounding atoms and even trivalent surrounding atoms. Okay, as I mentioned it already, A is representing total number of negatively charged units. Then you need to add, and here C represents total units of positive charge. Okay. Just note down even this formula also. Here I have given hybrid orbitals is equals to half of V plus M plus A minus C. As we know, I have given the direct formula for any species. This formula includes of all cases. I mean, whether it is neutral or whether it is negatively charged or it is positively charged. Positively charged. Okay, very good to see your results. Okay, so I hope you are very happy and try to listen the class also. So after checking out your marks, just follow the classes properly. I hope you are very excited and happy today for achieving a good marks in your board exams. Okay. Now I am trying to give few examples to work hybridization. Just try to work on these examples. I think you have taken the screenshot or you have noted it. Now moving on to the examples. Okay. Nowadays students, I'll apply the two methods, whichever is convenient to you, you can use the same. Okay. Now I need to predict the hybridization of xenon in XeF2. Some students may be having doubt, sir, does xenon forms compounds? Yes, it forms compounds. There are many compounds of xenon. Sir, is it not the violation of octet rule? Yes, it is the limitation of octet rule only. So I wanted to confirm this statement. Octet rule is not the universal rule to decide the stability of a given compound. Okay, right. So there are compounds of xenon. There are many limitations for octet rule. In future classes, once you attend the offline classes, all the details about the formation of compounds of noble gases we will be studying. Okay, right. We have a chapter named as P block elements. Under P block elements, we will study about each group, 13th group, 14th group, 15th, 16th, 17th and 18th group. Under 18th group, we will study about the compounds of noble gases. Okay, right. So try to predict the hybridization of Xe by using two methods. Method 1, which I explained in the previous class, and method 2 is the formula which I have given in today's class. Okay, this is method 2. Now as we are following method 1, we need to know the total number of valence electrons of xenon. Even in both methods, we need the information about total number of valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. I have written 8 electrons since xenon belongs to 18th group. Since it belongs to 18th group and has 8 valence electrons. So xenon has 8 valence electrons. All the 8 valence electrons I have. Okay, now listen carefully. Out of 8 electrons, I am trying to use how many electrons for bonding with 2 fluorines? As we know, fluorine is monovalent atom. Now I need 1 electron for each fluorine. Out of 8, I am using here only 2 electrons for bonding with fluorine. The remaining 6 electrons exist as lone pairs. In total, I have 3 lone pairs. Can you count the hybrid orbitals for XeF2 by using method 1? Here total number of surrounding atoms is 2 and total number of lone pairs is 3. Now it comes out to be 5. If my hybrid orbitals count is 5, and what would be the hybridization? What is hybridization? Can anyone tell me? It is sp3d hybridization. Right? Now coming to method 2. Directly I am writing the formula. Hybrid orbitals equals to half of number of valence electrons plus just I am writing only m, since there is no charge over here. Now try to substitute the values in this formula. Now the valence electron count is 8. As we know, xenon belongs to 18th group. Now number of monovalent atoms, as we know that fluorine or chlorine or bromine or iodine, if they are written as surrounding atoms, their valency is 1. Therefore here the number of monovalent atoms is 2. Therefore we are getting 10 upon 2. It's coming out to be 5. Hybrid orbitals count is 5 or steric number count is 5. Hence hybridization is sp3d hybridization. Is this point clear? Students, please check out both methods properly. It is very easy to find the hybridization of a given molecule. Hybridization prediction is very easy by using these two methods. Out of these two methods, try to find out which method is more comfortable for you. You can use the same. Okay. Which is more easier method according to your opinion? Yeah. Tell me your opinions. Which is the easiest way of prediction of hybridization? Prediction of hybridization is easy by using this method or that method. Whichever is convenient, you can follow the same. Okay, right? Shall we work on one more example? Students, are you there? I hope you are working on the examples. I hope the points are clear. I have given two methods. Out of these two methods, just check out your possibility. Whichever is convenient to you, you can use the same. Fine. Now moving on to the second example in today's class. Okay. Now let's try to work on XZF6. Try to work on XZF6. So whichever is convenient to you, you can use the same and try to find out the hybridization of xenon. As I told, we will predict the hybridization for central atom only, since the atomic orbitals of central atom will be participating in hybridization. Only the atomic orbitals of central atom participates in hybridization. Okay. Now try to predict the hybridization of xenon in XZF6. As we know, the xenon belongs to 18th group and has in total how many valence electrons? In total we have 8 valence electrons. Out of 8 valence electrons, we need to account for bonding with 6 fluorines. For this we need 6 electrons. How many lone pairs are left? There is one lone pair which is left, and therefore if I am counting hybrid orbitals, it is equals to total number of surrounding atoms is 6 and lone pair is 1. In total we have 7. If the steric number count or hybrid orbital count is 7, then what is its hybridization? It is sp3 d3 hybridization. Are you getting this? Okay. Next, moving on to the other example. You can try with method 2 also. That is your wish. If you wanted to try on method 2, you can follow method 2. If method 1 is convenient to you, you can use method 1. Okay, that is your wish. Now moving on to the other example. Dear students, try to work on NO3 minus. You need the hybridization of nitrogen in NO3 minus. Yeah, tell me. Okay. Right. So nitrogen is belonging to 15th group. Therefore, I have 5 valence electrons. 5 valence electrons. V is equals to 5. And there is 1 unit of negative charge. You need to add 1 electron. Okay. Otherwise, let me write V as 5 and number of monovalent surrounding atoms is 0. Since oxygen is a divalent atom. Oxygen is divalent atom. Therefore, you don't need to include oxygen in the formula. We need to add only number of monovalent atoms. Oxygen is a divalent atom. Here A becomes equals to 1 here. Try to apply method 2. I am trying to apply method 2 over here. You can use any of these methods. Okay. Right. So for better practice, I am giving one example with method 1 and one example with method 2. Whichever is convenient, you can follow the same. Right. Now hybrid orbital count is equals to 1 by 2. Valence electrons of nitrogen is 5 and number of monovalent surrounding atoms is 0 and 1 unit of negative charge. Then you need to add 1 electron. Therefore, we are getting 3. So hybrid orbital count is 3, hence its hybridization is sp2. Okay. Now dear students, now the chocolate question. Next question is, yes, try to give the correct answer for this question. Correct answer for this question. It is very simple, but it is very important example. ICl2 minus. It is example number 3. Try to predict the hybridization of iodine in ICl2 minus. Yes, try to find out the hybridization of iodine in ICl2 minus. Quickly, responses please. Students, try to predict the hybridization of I. Quickly. Quickly. Fast. Very easy to predict the hybridization. Students, if you practice prediction of hybridization during the bridge course classes, then you will rock like anything during the offline classes, okay? Because the same story we will be applying here. Once you have practiced during the bridge course classes, then you feel very, easy when you are working on during the offline classes, okay? Very good. Students are giving a correct answer. In ICl2 minus, the hybridization of iodine is sp3d. You can use method 1. I am going for method 1 now. 1, 2, 3, 4, 5, 6 and 7. Since iodine belongs to 17th group element has in total 7 valence electrons. 7 valence electrons, and it is gaining one more electron. In total, I have 8 valence electrons. Out of 8, I need to use 2 electrons for bonding with 2 chlorines. The rest of all electrons remains as 3 lone pairs. Now, the hybrid orbital count is equals to number of surrounding atoms is 2 and number of lone pairs is 3. In total, 5. Hybrid orbital count is 5, hence hybridization is sp3d. Now try to work on this example. Quickly. Next example number 4. Anyone please? XeOF4. I need the hybridization of xenon. With 1 or 2 examples, we will close the discussion about hybridization, and we will move on to the prediction of hybridization in hydrocarbons. Okay? Yeah, quickly try to predict the hybridization of xenon in XeOF4. Quickly try to predict the hybridization of, it is again one more chocolate question, but it is very simple question. The same story you are applying on the same formula. So what is hybridization of xenon in XeOF4? XeOF4. Responses please. Quickly. Now again the xenon. Try to apply your wish. I am trying to apply because for your better practice I am working on both methods. Okay, whichever you feel easy you can work on the same. Right? Since xenon belongs to 18th group, V is equals to 8. Okay, number of monovalent surrounding atoms is just 4. Don't include oxygen under monovalent surrounding atoms. Oxygen is divalent. Okay, now here fluorine is monovalent. Here there is no charge, therefore no need of taking C or A. Now use the formula HO equals to 1 by 2 into valence electrons are 8 and number of monovalent surrounding atoms are 4. Now it is equal to 12 by 2 coming out to be 6. If hybrid orbital count is 6, hybridization is sp3d2. I hope you are comfortably applying the formula. Okay, it is very easy. If you are able to predict the hybridization, 4 marks are in your pocket. In every exam, every year for NEET exam, in directly or indirectly, direct manner or indirect manner, you will get the question on hybridization and geometry of the given species. Okay, now let's move on to the discussion of prediction of hybridization for hydrocarbons. So we are going to apply hybridization topic for hydrocarbons. This is most important. Prediction of hybridization of carbon in hydrocarbons. As we know, hydrocarbons means the compounds which contains hydrogen and carbon. Okay, compounds of hydrogen and carbon. Now I have a simple short trick method for prediction of hybridization of carbon in a given hydrocarbon. Here I am trying to write look at carefully, listen carefully. Okay, here type of carbon I am writing over here, type of carbon, and here total number of sigma bonds, and here total number of pi bonds, and then afterwards we will write the hybridization. My dear students, if you apply any of those methods, you may not be able to get the right answer, since the hydrocarbons may contain more than one carbon atom. Okay, the previous methods which I have given, both methods are considering only one central atom. Okay, in all those examples which we have discussed, we have only one central atom. In hydrocarbons, we may come across certain examples where you may find more than one carbon atom. In such cases, the formula don't works. Now we need to adapt the other method. Okay, so the method of prediction of hybridization of a carbon in a given hydrocarbon, if you follow this one, it would be very easy for you. Now if you observe the carbon over here, if the carbon is involved with, students count the total number of sigma bonds. So if I am representing the bond with single line, it represents only a sigma bond. Now we have only 4 sigma bonds and there is no pi bond. Now we know that if 4 sigma bonds are present, hybridized orbitals count. As we know, hybrid orbitals count is 4 because total number of sigma bonds are 4. Hence its hybridization is sp3. Anyway, we don't include number of pi bonds. So then what about lone pairs? As we know, carbon has only 4 valence electrons. All of its 4 valence electrons are utilized in bonding. Therefore, there is nothing left as lone pair. Now coming to situation number 2. If you are observing carbon with in this situation. Now in this situation, if you observe, we have in total how many sigma bonds? We have 3 sigma bonds and 1 pi bond. If you are coming across any carbon with 3 sigma bonds, its hybridized orbital count is 3 and hybridization is sp2. Now situation number 3. If you are coming across carbon with triple bond, or if you count the total number of sigma bonds and pi bonds, we have in total 2 sigma bonds and 2 pi bonds. Don't include pi bond in counting hybrid orbitals. Now hybrid orbitals count is equals to 2, hence hybridization is sp. Okay, and fourth situation, if you come across any carbon under this situation, now if you count the total number of sigma and pi bonds over here, 2 sigma bonds I have and 2 pi bonds I have. Again 2 sigma bonds and 2 pi bonds. Hence our hybridization is coming out to be sp. With this trick, you can easily predict the hybridization of a carbon in a given hydrocarbon. I hope this point is very clear. This is a very easy method and easiest method trick to find hybridization of carbon. Shall we work on the examples? Okay. So here students listen carefully. So if you count the sigma bonds count is 4, hybridization is sp3. If 3 sigma bonds sp2, 2 sigma bonds sp, and 2 sigma bonds sp. Students, you may not count the total number of sigma and pi bonds in all the times. So it's better to use the trick in this way. If a carbon is not having any pi bonds, yes, you can easily observe the pi bonds. If carbon of a given hydrocarbon is not involved with any pi bond, its hybridization is sp3. If the carbon of your hydrocarbon is having only one pi bond, its hybridization is sp2. If the carbon is engaged with 2 pi bonds, its hybridization is sp. If the carbon is engaged with again 2 pi bonds, its hybridization is sp. In other words, if it is engaged with 2 pi bonds, automatically 2 sigma bonds will be present. Have you got this point? I hope this point is clear. So we will be working on prediction of hybridization of carbon in a given hydrocarbon. Shall we move? Have you taken this screenshot? Is this point clear? Is this point clear? Okay, moving ahead. So now, dear students, I am trying to give examples of prediction of hybridization. Now, question number 1. Find the hybridization of all carbons in the following compounds. Okay, now students, you will be given the examples like this: CH3, CH double bond, CH, CH2, CH double bond, CH2. If I have given a compound in this way, can you predict the hybridization of each carbon? CH3, CH2, CH double bond, CH2, CH2, C triple bond, CH. Now the third example is very famous compound. Now can anyone tell me hybridization of each carbon in the benzene ring? Like this we can write many examples. Okay, right? Now try to predict the hybridization of each carbon. As we know that I am trying to represent over here, this is the position of carbon, this is the position of carbon. As I have already told or explained in counting sigma and pi bonds, I told that the organic compound can be represented with bond lines. Okay, students, tell me what is hybridization of the carbon atoms in example number 1. As I told, just look at the carbon. Does this carbon involve with any pi bonds? Students, response please. There is no pi bond which is associated with this carbon. Does this carbon involve with any pi bond? Does this carbon involve with any pi bond? Since this carbon is not involved with any pi bond, its hybridization is sp3. Okay, very nice. Now this carbon is engaged with how many pi bonds? 1 pi bond. Hence its hybridization is sp2. Again this carbon is involved with 1 pi bond. You need to look at on both sides. Okay, you need to look on both sides. Now this carbon is not engaged with any pi bond, hence its hybridization is sp3. This carbon is engaged with only 1 pi bond, sp2. Again sp2. I hope you are able to write the hybridization of each carbon in a given example. Okay, let's try to work on this second example. Since this carbon is not engaged with any pi bond, hybridization is sp3. Again sp3. Hybridization of this carbon is again, there is 1 pi bond sp2. Here 1 pi bond sp2. There is no pi bond sp3. Here this carbon is engaged with how many pi bonds? 2 pi bonds. Hence its hybridization is sp. Again, the last carbon hybridization is also sp. Now students, this is a chocolate question. Chocolate question. Try to give the proper answer for this compound. Okay. Now I will try to discuss even this example also. CH2 double bond, C double bond, CH2. Okay. Can anyone tell me hybridization of each carbon in benzene? Hybridization of each carbon in benzene. Since if you observe carefully, each carbon is engaged with at least one pi bond. Each carbon is engaged with pi bond. Yes or no? Each carbon is engaged with pi bond. Therefore, all carbons of benzene are what hybridized? sp2 hybridized. All carbons of benzene are sp2 hybridized. Okay. Now you can easily predict the hybridization for this compound. You can easily predict. Now try to work on sixth compound. If you consider this compound, which is cyclohexane, we can call it as cyclohexane. Since all the carbons are saturated, I mean there is no pi bond which is engaged with any carbon, and hence each carbon hybridization is sp3. Right? Now you can find the hybridization even in this compound also. This carbon is sp2, this carbon is sp2, or rest all carbons have sp3 hybridization. I hope you are able to write hybridization of carbon very easily. Now if you observe this carbon, now this carbon is engaged with only one pi bond, hence sp2 hybridized. This is again chocolate, one more chocolate. Okay, now this carbon is engaged with how many pi bonds? People may mislead in this example. You may find like hybridization, you may predict it as sp2, but it is not correct. Since this carbon is engaged with how many pi bonds? Since this carbon is engaged with 2 pi bonds, its hybridization is sp, and this carbon is sp2. I hope things are clear. You are able to predict the hybridization of carbon in all these examples, right? Organic chemistry, probably I'll start from tomorrow. We may be left with only 2 days. I'll try to give some important inputs about organic chemistry, right? I'll give chocolate once you attend the offline classes. Okay, right. With this I will stop for today's session. I hope you are able to predict the hybridization of each carbon in hydrocarbons and in any given species. Okay, please continue to work for a few more examples. Okay, and thank you. And if the video is useful to you, you can share the video to your near and dear friends. If you feel like it is worth, you can like the video and forward the video to your friends. So thank you. That's all for today's class. Have a nice day. And once again, congratulations to you all for securing or achieving good marks in your 10th board exams. Continue to work in the same manner, and hopefully in future you will be getting very good marks in your board exams as well as in your NEET exam also. Thank you.